this already. The derivative of a constant function. So a constant function is just a number, like 7 or 8. We know that the derivative of a constant is 0. We've talked about this already. Remember, the first derivative of any function is the tangent slope. So they could ask for the first derivative or they could ask for the tangent slope, right? Those are interchangeable. Power functions, we've already talked about these. We next looked at the function f of x equals x to the n, where n is a positive integer. If n is equal to 1, the graph of f of x equals x is the line y equals x, where the slope is 1. So basically, the derivative of x is 1. And we've talked about this before. This word, when they go d over dx in front of it, this is just saying the derivative of, in function notation. Leibniz notation technically. The derivative of. The derivative of x is 1. We've talked about this. The derivative of 7x would be 7, correct? Because remember, anything like this, remember what we do? We take the exponent, we drop it in front, and then subtract 1, right? So it'd be like 2 minus 1, but we're just not showing that math. We're just saying, oh, it's just a 1, right? But technically every time we're subtracting 1. So that's where you get this formula. So the power rule, d over dx of anything x to the n drops in front, and then, bless you, we take n and we subtract 1 from it, right? That's all we're doing every single time. We're just not showing the actual math of that. So example 1, do it. So this one says if f of x equals x to the 6, then we have to use function notation. So we have to go f prime of x equals, drop the 6 in front, x to the what? 5, right? Okay, B says y equals, so this is just a whole bunch of different notations. I'm trying to get you used to seeing the different notations and what they mean. They all mean find the first derivative. So this one's y equals, they give us an actual function, then they want y prime. Well, y prime equals 1,000, we drop it in front, x and drop it by 1, 999. Okay, this one gives us y equals t4. So this is dy with respect to dt. So instead of writing y prime, they can use this Leibniz notation, and dy is this one over dt is whatever variable that is. So if it was y equals x to the 4, it would be dy over dx. If it was y equals smiley face to the 4, it would be dy over d smiley face, right? It's just another way of showing the same thing instead of y prime. So dy over dt would equal 4t cubed. And then our last one, they're saying the derivative of x cubed, and then you just put equals and you give the answer, 3x squared. Negative integer exponents, we've already talked about these too. So 1 over x. So they want the derivative of 1 over x. How can I rewrite 1 over x? X to the negative 1. I can't write that there. I can go d over d equals d over dx, the derivative of x to the negative 1, right? What is the derivative of x to the negative 1? Negative 1, x to the negative 2. And if they so chose to put it in positive exponents, the negative 1 is not to the negative 2, correct? The only thing that's to the negative 2 is that x. If the negative 1 was to the negative 2, it would be in brackets, which it is not. So the negative 1 stays in the numerator, and then x to the 2 drops to the denominator. So both of these are correct. Fraction exponents we've also already talked about. If anything is in a radical, we will immediately write it in a rational exponent, so a fraction exponent, to do derivatives every single time. So people say, well, when don't I? Always. So never. You will always change this to a fraction exponent. So remember, this is a 2, because the index is a 2 if it doesn't exist, and this is a 1 if it doesn't have an exponent. So it's x to the half. I write it as f of x because I've not found the first derivative. I just rewrote it in a different way. Then the first derivative, f prime of x, would equal 1/2 x to the what? Negative a half, which we did today a lot of, right? in our practice example before we started. Okay, then we're going to flip over. So like I said, this has been pre-taught. So it should seem like you already know what you're doing because you taught it. Okay, so same thing, the power rule general version is for any real number. So if ever you have one term, quiet please. If you have one term, well, a variable, just one variable to any numerical exponent, it will be allowed to use the power rule. Make sure you're paying attention and not on your phones. F of x equals, how could I rewrite this? 1 over x squared. X to the negative 2. Waller, put down the paper. So f prime of x equals what? Negative 2x to the negative 3. Okay, p is the cube root of x squared. So we have to first rewrite it. And it's going to be x to the what? Yeah. 2 over 3. Because remember, you take whatever the index is and you drop it underneath, right? I always draw an arrow when I used to teach this in grade 10 a long time ago. So I taught grade 10 in 2010 the last time. But you just take the arrow and you drop it underneath. Oh, gosh. Wouldn't that be great, though? It would be enlightening. You don't even know how to do the moving rate. All right. So y prime equals 2/3 x. Now what's 2/3 minus 1? Negative 1/3. Okay, I want you guys to graph this graph. Go. Graph this graph on that Cartesian plane. Where does this graph start at? X equals what? 0. So if we go to do a t-table, an x and then an x root x to give me my y, I can start at 0, and then I get 0 times root 0, which is 0. I could do 1. 1 times root 1 is 1. Then I would probably do 4 and 9. You do decimals in between if you want. So if we go to sketch it, we're going to get 4 times root 4, which is 8. And then we're going to get 9 times root 9, which is 27, which is too big. Okay. So unless we change our scale, which I don't feel like doing. So we have 0, 0, 1, 1, and then 4, 8. So it's looking something like this. Is it doing that, do you think? Or is it curving the other way? Do you think we have enough points to know? No. So we have to throw in another point. What about 2 and then 2 times root 2? What is that? Grab a decimal. 2 root 2. What do we get? Pardon? 2.82. So we go 2 and 2.8. Okay, what about 3? 3 times root 3. What's 3 root 3? 5.19. Wow, that ain't a 2.8. How did no one correct that? It's 1.8. Try again. Oh my gosh. Oh my gosh. Come on. Well, that's an erase. Sorry, what was 3 again? 5. Okay. We want the tangent line and the normal line to this curve at 1, 1. So we want, at this point, the tangent and the normal, correct? Where does the tangent come from? The first derivative. So let's talk about m tangent first. So if y equals x times x to the half, I'm not going to do product rule. I'm going to put those together. What is x to the 1 times x to the half? X to the 3 halves, because it'd be 1 plus 0.5, which is 1.5, right? Which is 3 halves. Then I can find m tangent really easily, because you drop that in front, so we get 3 over 2 x to the what when you subtract 1 from it? What's 3 halves minus a half? What's 1.5 minus, what's 1.5 minus 1? A half. So you get 3 halves x to the half, correct? That's a general m tangent. I told you x is 1 and y is 1, so I'm going to do m tangent equals 3 over 2, 1 to the half, which is 3 over 2. How do I get the equation of the tangent? What did we fill it into? Y minus y1, which is m, or which is 1, times equals m times? What is m? M is 3 over 2. 3 over 2, x minus x1, which is 1. So I'm going to get y minus 1 equals 3 over 2x minus 3 over 2. The reason why I'm getting in this form is I need to graph it. So I want it into y equals mx plus b. Add 1. So I get y equals 3 over 2 x what? What's 1? Negative 1.5 plus 1. Yeah, negative half. So this is the equation of the tangent. That's the equation of the tangent. Right? So how do I plot that? I plot the negative a half first because that's my y-intercept. Right? This is in slope y-intercept form. So I plot my negative a half first because I need a starting point. So I go to negative a half, which is here. Here's negative a half. It's a little low. Negative a half, right? And then I need to do slope. Up 3, right 2. So from here I'm going to go 1, 2, 3 up, right 2. And when I connect those, where do they go through? 1, 1. So you're going to draw your y-intercept of negative a half, then you're going to go up 3, right 2, up 3, right 2. So it's going to end up going through here too. And you're going to get your tangent. Now your normal line is perpendicular to that one. Your normal line is perpendicular to that one. So if my m tangent, grade 10 comes in a lot, I'm not joking. If my m tangent is 3 halves, my m normal is 90 degrees the other way. So it's a perpendicular line to that. So if the slope in grade 10, we were taught, if the slope is 3 halves, what's the perpendicular slope to 3 halves? Anyone remember? We literally taught that for this moment in time. 2 over 3 does help. 2 over 3 would help. So let's think about this. If I have a slope, let's watch this. Let's just do a normal slope. So if I start at 0, 0, and I have a slope up 3, right 2, it would be here, correct? If I want something perpendicular, I want it at a 90 to that, yes? Which means if this is a positive slope, at the very least, I know the perpendicular one is negative to make it go the other way, right? So I know if the tangent is 3/2, I know that the normal is going to be negative something. Negative 2/3. Let's see, because I need to make it run the other way. So if it's negative 2/3, which is what Ashton's telling me, that means I'm going to go down 2 and right 3, and it's going to run like this. And that would make me have a 90, wouldn't it? So actually, the perpendicular slope to a regular slope is the negative reciprocal. So if the original slope was negative, the perpendicular slope is actually going to be positive, because it makes it run the opposite direction. It has to be the opposite sign of the slope. You learned that in grade 10. Okay, so it's negative 2/3. Okay, so same thing. We're going to get y minus y1 equals negative 2/3 x minus 1, x1, add my 1 over. So I'm going to get y equals negative 2/3 plus 2/3 plus 1, which actually gets me negative 2/3 x, plus 5/3. So 5/3 is like 2.3. No, 1.3. No. Yes. Oh gosh. Do 5 divided by 3. My brain is helpful. What's 5 divided by 3 is decimal? 1.6? 1.6? Yeah, 1.7. So it's 1.7. So let's say, I'm going to use different numbers. It'd be 1.7 would be my slope. And then I'm going to go down to right 3. And where's it cutting through? 1, 1 again. So this is the normal equation. And it's perpendicular to the green one, correct? So if I ask you for the normal equation, you still have to find the tangent slope and then flip it and negate it, right? So even with the normal slope, you still have to find the tangent, flip and negate. I want to get it with a spitball. I don't even know what just happened there. Okay, differentiate, go. Okay, so this one, we get 4x cubed minus 3x squared plus 5x to the negative 1 minus x to the 5/4. Okay, all I did was rearrange it to be so that we can actually do the derivative of it, right? I have not found a derivative at all. I've just mathed it. So y prime equals 12x squared minus 6x minus 5x to the negative 2 minus 5/4 x to the what? 1/4. So if they want to rewrite this, they can as in 12x squared minus 6x minus 5 over x squared, and then this would be minus 5 over 4, the 4th root of x. Would be another option. Okay, then we have d over dx of this. So they're telling you to find the derivative of this, which I'm going to rewrite as d over dx of negative 3x to the 6 minus 5 plus 7x to the negative 4 minus x to the 2/3. So the derivative of that is negative 18x to the 5 minus 5 goes away, minus 28x to the negative 5, and then minus 2/3 x to the, you subtract 1 from that, you're going to get what? Negative 1/3. So if they want to rewrite it, they'd go negative 18x to the 5 minus 28 over x to the 5. And then minus 2 over 3 cube root of x.
Do we have to rewrite it, or can we leave it as
I'm doing both because the answer keys sometimes are different in the textbook, because different people must have done different answer keys in it. So sometimes the person who did the answer key leaves it negative, and sometimes they don't. Sometimes they leave it as a rational exponent, sometimes they don't.
But if we were to do that on the test, it wouldn't matter?
Written response wouldn't matter, multiple choice, you have to match what's there. Yeah. All right. This one comes up a lot and people forget about it. So here it says, find the points on the curve y equals x4 minus 6x squared plus 4, where the tangent line is horizontal. Tangent line is horizontal. What the heck does horizontal mean? And everyone forgets about these. What does horizontal mean?
Last row.
Horizontal? What is it? What is the horizontal line? What is the slope of a horizontal line? 0. So if they want where the tangent line is horizontal, they're asking where m tangent equals what? 0. So they're giving you what m tangent equals. So we have to find the tangent slope of this one first and set it equal to what? 0, and then we can solve for x. So it wants the points. So we'll solve for x that way, and then we have to input it back in to get our y's, because it wants points. It wants x, y's. So if they tell us the tangent line is horizontal, they want to know where the points for that happens, we have to go y equals x to the 4 minus 6x squared plus 4, and get our m tangent first. M tangent is just the first derivative. So that will be 4x cubed minus 12x. And where m tangent is horizontal, what is our m tangent? 0. So 0 equals 4x cubed minus 12x. Now some people say I have to do synthetic division. Do you actually have to do synthetic division for this one? You could take out a GCF of what? 4 and x. So we get 4x, and then we're left with x squared minus 3. Do we agree? Then we just keep solving like we did in every other mathematics class we were in. 4x equals 0. X squared minus 3 equals 0. Divide by 4. X equals 0 is one of them, one of the x values. They want the points though, correct? So 0 and something is the 1 point, right? If they said the x values of the horizontal, we would be done once we're done this, but they said points. And then here we're going to get x squared equals 3, and then we have to take the square root, and when we physically move our hand like this and take the square root, we have to remember what? Plus and minus. So x equals plus or minus root 3. It wants the points. How do I get the y if I know the x? Plug it back into the original equation. So I'm going to get y equals 0 to the 4 minus 6 times 0 squared plus 4. So y equals 4. So 0, 4 is one of my places where I have a horizontal tangent. Then I put in my root 3. Y equals root 3 to the 4 minus 6 times root 3 squared plus 4. Y equals what? I think it's 5, but this one gets you a 5, right? This one's negative 5? Oh, it's negative 18 and 9. So this one's going to be root 3 to the 4 becomes 3 times 3, which is 9, and 4, and then minus 18. So this one's going to be negative 5. And then this one's going to be negative root 3 to the 4 minus 6 times negative root 3 squared plus 4, which should still be negative 5. Because this will just make them positive. Can you guys do me a favor and type this into your calculator? And I have my nice this up so I can actually type my calculator up here. So we're going to type it in. Type the original into your calculator because you're going to see what you just found without even knowing it. I want to let this T rise. So type in your original and you'll see what you just found, which is actually next unit's findings. No, it did not expire. Well, it was a nice thought. Can you guys find the max and mins of the graphics in front of your face? Go. Max and mins, find them. If you look at your graph in front of you, I'll put it back here. You have a graph that looks like this. True? You guys have a graph like that, yes? Yep. Guys, the horizontal tangent, we've talked about this before. The only place you're going to get horizontal tangents is at what? Max, mins, and points of inflection, correct? Yeah. So, this one is 0, 4. This one, guess what? Negative root 3 and negative 5. This one is at root 3 and 5. By finding where the horizontal tangents exist, you just found the maxes and mins off of a degree 4 graph. Could we find the maxes and mins in 30-1 algebraically? No. If ever I asked for a max or a min in 30-1, you guys have to use your calculators. That was the only way I could ask for them. But now, can I ask for them algebraically? Yeah. You have to find the first derivative, set it equal to 0, and find those x values where that exists. It's called the critical numbers. All right. Example 6. The equation of the motion of a particle. This is the motion of the particle S. S is measured in centimeters and t in seconds. So they want the acceleration as a function of time. What is the acceleration after 2 seconds? So just so you know, S is your position equation. S prime, so the first derivative of S, everyone's paying attention to me? Yep. Is actually the same as V, which is the velocity equation. So if I give you a position equation, if you find the first derivative of that, you've actually found the velocity equation. And S double prime, which is equal to V prime, equals A, which is the acceleration equation. Now, it makes sense because of the units of measurement. So, if S is in centimeters and T is in seconds, this is going to be just S. And S is going to be in centimeters. It's the position equation, correct? S prime is actually going to be the derivative. And the derivative is going to be ds over dt, which is actually centimeters per second, which is what? The velocity answer, right? When you do velocity, it's meters per second, kilometers per hour, centimeters per second, right? And this one is going to be d2s over dt squared is how they write it, which is centimeters per second squared. So if they want the acceleration, what are they indirectly asking me if they give me the position function? Second derivative. It's a fancy way of asking for the second derivative, right? And when it's power rule, it's pretty easy. So S equals 2t cubed minus 5t squared plus 3t plus 4. S prime is 6t squared, which is V. minus 10t plus 3, and then a equals v prime, which equals s double prime, which is 12t minus 10, right? So that is the acceleration as a function of time. What if they want at 2 seconds? Well, that just means they want a of 2, which is 12 times 2 minus 10. So it would be 24 minus 10, which is 14 centimeters per second squared.